Okay. Today we're going to talk about the feature selection. Remember, the first time we drawing the decision tree, at that time, there are a lot of attributes. We want to choose which one be the top attribute, right? Due to the root, due to the node, due to the others branches of the attribute. So today we'll introduce you how do we determine not just by your eyes, because by your eyes, 14 instances are very easy. But now we will face the millions, thousands data. We cannot just build by pencil by your head. So we need some algorithm to help us. So today we will focus on the Gini index and entropy and information gap. No matter what, maybe at least we can mention two of them. Information gap maybe next time. So when we make a tree induction, then we'll have a lot of strategy. First is greedy strategy, The greedy strategy will split the records based on attribute tests that optimize the certain criteria. For example, there are a lot of issues. First, how to specify attribute is testing condition, how to determine the best split. We will discuss follow one by one. First, how to specify test condition. The first one is to determine by the attribute types, because we will face the nominal attribute, ordinal attribute, and continuous attribute, right? So different attributes have different methods. The second part is depends on the ways that split. At least we have two different ways. First is two-way split. The second way is multi-way split. Yeah, we will mention it one by one. First, split based on nominal attribute. If you want a nominal attribute, there is just split multi-way. You have family, sport, luxury, three different attribute values. Then you will split in three branches. But if you want to use the binary split, when we'll use the binary split only card algorithm. The other algorithm, for example, ID3, C4.5, C4. These two algorithms is multi-way. And the last time we mentioned in our class, the assignment and also the exam, we all use the multi-way. But sometimes if you use the binary way split only for card algorithm, you will combine two of them together. Or this. It could be acceptable because it's nominal only for card algorithm. For ID3 and C4.5, it's not allowable, especially for original Hans algorithm, which I introduced you in the class. And when we face to the ordinal attribute, for example, small, medium, large, and ordinal, right? So when we combine together, multi-way is very easy. One just one branches. But the binary way will combine the similar together. Small with medium, medium with large, right? I think it is easy to understand. But if that makes sense, use the small with large and medium alone. So when you face this kind of problem, especially when you face an interview, please pay attention to me. Even if my voice is not good now, but I want you pay attention to me. When you face an interviewer, examiner, the interview officer, they ask you questions. Can we do that? Usually not, right? Small with large, medium, single, right? But the best answer is depends on. When you reply the interview officer, It depends on means you will give an example, explain in what kind of situation this is better, in what kind of situation the other example is better, because this is very important. I will translate into Chinese. 同学们，你去面试的时候，万一碰到了一个题目，你没有把握标准答案是什么的时候，有一个很好的答案就是 it depends， 取决于情况。通常你讲出这一个的时候，面试官会非常惊艳，但是你不能停在这里，你要告诉我，那情况 A 是这样，情况 B 是这样，只要你讲得出例子，都比单一对的那个答案更好，因为表示你有思考过，而且在很短的时间可以给予不同的情况、不同的例子，这样的答案会比单一不确定的答案回答可或不可都还要好。听懂我的意思吗？这是面试很重要的技巧，听懂吗？ So in this case, is that a good split? 好，一旦我跟你讲 depends on， 我就要举出一个 depends on 的例子。For example, binary cutting, we can be medium with small or medium with large, right? But it could be the small with large, medium single. Yes, sure. In the population, this is the population. And the x-axis is means age， 这边是年纪，这个是人口。As you know, if we face the labor force question, labor force 是人力市场的探讨。Lower than 50 years old, not count, right? According to the law. 15岁以下是不能算，还是16岁？同学。台湾的法律不是有统风吗？根据内政部，人事行政局，15岁以下不能算劳工。一般人上几岁以上，我们不算人力资源。65岁以上，对吧？所以从年纪 young and old combined together will not count as a labor force. Only between the more than 15 and less than 65 will count as a labor force. Then we will say, if we divide it into 3 parts, the small and the large could be combined together because they could be viewed the same category. There is not count as a labor force part. OK? 同学，我们这样回答我都不知道是因为我声音太难听，还是我英文没听懂。还是你真的没听懂？告诉我刚刚讲的你有听懂吗？好，我点个头至少让我知道有人听懂了。So in this case, small and large will combine together. Yeah, and medium will alone. This is the order scale. And the third one is continuous attribute, 连续型的变数。Continuous attribute could be 2 methods， 很重要哦。来 ，First is 我们在离散化的时候2种，一种叫静态离散化 （static discrimination）。What is the static? When you give the survey questionnaire, you lock the arrow brick. For example, 10 years old, and 11 to 20, 21 to 30. Then you give the block, right? It's fixed. That will be static. 就是你让人在填问卷的时候，你固定了那个区间，10岁以下，11到20，20到25，25到30，35到40，你已经固定了，这叫 static。就是这叫 static 静态的离散化，行吗？回应我，行吗？另外一个是动态的dynamic 的，动态的呢 ，just like equal interval 跟 equal frequency， 这是不是我们跑数据的时候用的？那动态的只有你收集到原始的数据才有办法动态。 不然其实都只能静态。那什么时候你会收集到静态的？你让使用者填问卷的时候，就会收集到静态的，因为收入的年龄是敏感性资料，对吧？一般大家不想填的基准，特别是年纪，到底要算农历、新历还是11个月39、39天为29天为的难算，通常都给区间。那真正可以做到 dynamic 的，就是它一开始就输入的出生年月日，所以你会看到现在系统都这样做，因为它背后就可以自己算，不让你去弄了，行吗？好，那还有一个蛮重要的就是 ，if you want to use the static， 你的年纪、你的收入那一些值，最好都跟你的问题有关。好，同学们很奇怪，尤其是我们现在大学生，你的 viewpoint 是大学生。你就会用883字语库，这是对的。所谓的问题是跟大学生有关，懂我的意思吗？最好还是有你的问题跟什么有关？有这个问题是跟劳力有关，那你就要去看法定几岁以上开始就算劳力，可以吗？啊，或者是人事行政局，我们的 government how to lay build the static range that would be the better choice， 是他自己定，懂吗？那一般隔5岁 make sense， 收入隔1万 make sense。And the other point is use the binary. Binary just like the example. Do you remember the first time we built an attribute digit tree, right? And finally we cut smaller than 80 and larger than 80. Do you remember that? 记得吗？用 K 来做决定 ，it's a binary， 找一个数字小于它或大于它，这个可以用。Okay, I will ask you. This is the dynamic or statistic binary split， 这是静态还是动态？找一个数字切2半，静态还是动态？静态，行吗？ You find a number and split it two way. Is this static or dynamic? 这个静态还是动态 ？Static or dynamic? 好，这个 Is that equal interval? 因为 dynamic 只有 two measure equal interval equal frequency。So this is static. 不要以为老师问你这是不是静态，你就说这个是动态。No, depends. It's not equal interval. 没有数据显示它 equal frequency， 所以这就是人定的 static， 因为它这一句都不多少就多少 static。只是一个是 two way， 一个是 multi way。那我们来看，那我们要决定 ，Do you think which one is the better split? There are original 10 records belongs to class 0, 10 record belongs to class 1。也就是说，现在有2类 ，class 0 10B，class 1 10B。Then they pick up 3 different attributes: on time, part time, student ID. Then they're doing the following things. If we use the on card, yes, C0 have 6, C1 have 4, C0 have 4, C01 have 6. This is belongs to no card. This belongs to have card. Do I use the on card to make it more clear? Compare 10-10. 都比原来的实体值还要干净一点点吗？实体值是如果，是不是？ Original 10, 10. It means 5 compares to 5, right? But in this case, yes, could be 6 to 4. This could be 4 to 6. Is that more clear than original? Yes, but not very clear, right? Okay. The second one, use the card type. This attribute have 3 branches. First is family, and C0 is 1, C1 is 3. More clear, right? In this case, sports, C0, 8, C1, 0. It means as long as I ask you, are your card type is sports? If answer yes, then I will say you are all class 0. No excuse, no exception. 对吧？分得很清楚。And if I ask you, is your car type luxury? 奢华型的。Oh, then I will tell you there are C0, 1, C1, 7. Do you think this is more clear next to the data belongs to 0, class 0 and class 1 more clear? 这边分得清楚，还是这边分得比较清楚？把这2类本来是10个人、20个人混在里面，一半是 zero， 一半是 one。我现在用这个问题问下去之后，它分出来是6446，这里分出来是13817，谁分的比较干净 ？First or second？ Second， 同学你回答问题，我们讲谁呢？你不回答我都不知道，是没讲清楚，还是我没有让你听懂？哪一个比较干净？还是你真的不知道？定义干净就是把这2类分得很清楚。The clear means class 0 will close to class 0, class 1 will close to class 1。这个原本5坡它是分成6446，这个它可以分成1:3、8:1:7。也就是说，如果少数是杂值的话，这个1会被挑出来是错的。这个1会被挑出来是错的，其他都可以分得干净，对吧？那哪里分得比较好 ？On card 还是 card type？card type 对吧？我好像只跟这个人上课，其他人是没有要听的嘛？听一下好吗？对，第一是100，不代表第二次跟第3次也是啊，后面的作业也要写啊。那我们来看一下第3个。If you think if I have 20 attribute value， 就是我 ID 有 C1 到 C20， everyone belongs to one category. It's very clear. Is that good? 是不是每个人都不一样很干净？但这个好吗？不好，不好的原因是没有人回答我。不好的原因是，为什么3不好？是真不知道还是不愿意回答我？我想要了解一下。真不知道你举手。不好意思回答我举手。哦，好 ，excuse me。那你没有回答我的原因是什么？嗯，所以你是第9，你不知道哪一个对啊？
那你可以跟我讲你是第一，我也希望你是第一种还是第二种。你不知道你答案对不对，但你答案问，就知道答案的是多少举手。我觉得你呢？这是你的答案，是因为分太多嘛？它的模式太接近了。那同学你呢？分析的意义是什么原因？我们小考才考，我一直问这题的小考才考，这么多100多分，怎么可能没人知道？帮我吗？怎么可能？就是变成每个人爱好，就是都是有爱好不一样啊，什么这样就没有意义？但是你这题小考错误，你如果错就跟别人的关系。很多独立，既然都独立的话，那就是。第一个，你用独立这个词就不正确，因为独立在统计上有特别的不能用，你这叫不重复，这是第一个。第二个，既然不重复，就没有分析的意义，为什么？就没有找到其中的关联。对，很接近的，但其实老师用的词一直都是 pattern 模式，重复的 pattern。助教是个都给大家对的，是不是？助教该这么说吗？没有写到 pattern 这个字，应该都要算错。因为关联也是另外一个关键字，关联法则是另外一个重要的意义。这个是行话，行话的意思就是这个行里面的人没有人都知道。同学，我知道你将来要走这一行，但是我希望你的毕业证书你要知道这个话。同样的这个 attribute ID 为什么不可以用 ？The reason ID cannot be used is just because there is no other data will have the same value. Hence, they cannot be induction. 不能归纳 can be induction, then can be deduction. Understand? Thank you for your reply. 谢谢其他前面的4位同学。好，那比较到我说前面有被我问到，我下次会到后面去，比较干扰他。So, you will say, Professor, isn't fair. If we use the 2 attributes, is it clear? If we use the 3 attribute value, it's also not clear. I mean, unfair. This is I use the more attribute value, but it's more clear. But when we use the extremely case, we use the ID. Everyone is different, but the value you also not accept. So which kind of attribute value is a better attribute to choose? Then we will introduce another concept. We call that impurity. Impurity. Great strategy tries to use nodes more homogeneous. 什么是 homogeneous？ 同质性。英文不清楚写下来。同质性。如果 the nodes with homogeneous class distribution are preferred, because, for example, this is homogeneous or non-homogeneous. Oh, that might have to answer again. It's homogeneous or non-homogeneous. Is that homogeneous or non-homogeneous? Sorry, because nobody answered me. I just have to ask one by one. Yes, this is not homogeneous. And we also will call that high degree of impurity. So is that homogeneous or not homogeneous? Yes, because 9 belongs to C1, C0, and 1 belongs to C1. So it's higher, more homogeneous. It means lower degree of purity. So impurity is measure the node, the one to 越乱越不好. We don't like the impurity. So we need the index to measure the node impurity. So today we'll introduce 3 different attributes: index, Gini, entropy. But maybe we do not go into the second one because the first class we just discussed our chapter 1. So maybe Gini index will be the first one. And the classification error will be next week. So please pay attention to this part. Okay. So suppose before the stability, there are 2 classes, C0 and C1. This is the total instance of the C0. This is the total samples of the C1. The class, we call that M0. Before stability, it will have a purity, 对吧? Now we will test A is better or B is better. 公平一点, be fair. We use the only 2 way. 这个是 2 branches. This is also 2 branches. Then we will find A will divide it into node 1 and node 2. And then we recalculate. In node 1, how many in C0? How many in CC1? Then we will find the impurity and 1. Okay. And the same. Compute the N2. We will find how many in C0, how many in C1. Then we will have the 2 instances. Calculate the impurity M2, right? So M1, 2 combined together is after stability. So the gain means original. The impurity is M1, M0. For example, the original impurity is 0.9. For example, but after stability, my impurity becomes 0.4. The same way, we compare the attribute B and do the same things, and we find this and 3, 4, the impurity become 0.5. So we will compare original M0 and M0, and A is the attribute to get to the M12. B is the attribute to get the M34. Then we will compute how many they get. For example, the attribute get 0.5. The attribute B before and after they get 0.4. So which attribute is better, A or B in this case? A or B? Yes, that's because original is 0.9 and after it becomes 0.4. It's impurity, right? So when original subscribe the after get more means better. So we will pick A or B as the attribute to grow the tree. Which one? A, yes. So this is the concept, but we need a formula. The formula Gini index here is a little bit complicated, but just follow. For example, there are total 6. And we calculate. The first one, 0 divided 6. The second one, 6 divided to 6. So the first one is 0. The second one, probability is 1. So we use the 1 to subtract 1 squared
subscribe E 1 0 squared and 1 squared, it will equal 1 subscribe 0 squared and 1 squared is still 0. It's perfect because is that clear? Is that clear? Yes. So finally, impurity is 0. It's the best case for Gini. And the second case is 1 5. This is 1 divided to 6, 5 divided to 6. And we use the 1 subscribe first square and the second square. Then we get to the 0.278. The third one in the same method, we get the 0.444. So when the impurity increased, the Gini index also increased, right? Does that make sense? Yeah. So we can tell you the impurity of Gini, the maximum is 1 to subscribe. If you are 2 category, it just like 1 divided to 2. Okay, it's 1 second. So the maximum will come 0.5. Okay, the text also tell you the worst case is 0.5. But please be quiet, okay? But if all the records belongs to one class, it means the purity, most interesting information, the answer will be 0. Okay, understand? 可以吗? Yeah.
Okay, so the higher the GB, the better the result is it, correct?
You mean Gini what?
The result. The higher the result, the better.
Lower. The lower is the better because Gini index is measured impurity. We don't like impurity. Okay, we don't like impurity. So, but it's getting lower. It's not impure. We like this one clear. Okay, it's measured whether the classification is good or not. That's for your question. So, this is the first step. The second step, I will let you know. It will appear in your exam. The Gini index used in CART, Squillic, and Sprint, 3 major algorithms. So they use the Gini index. And when a node P is split into K, it means we have to have the weighted of each node, child node. I'll give you example. For example, originally there are 12 examples. C1 have 6, C2 have 6. Without calculation, you know the Gini index is 0.5, right? Worst case. But we use the B attribute. When your answer is yes, you become N1 here. And we find that the result is 2. C1 become 5, C2 become 2. And when he answered no, the N2 case is here. C1 become 1, C2 become 4. And how to compute the Gini index here. N1 here, because total are 7. So 1 subscribe 5 divided to 7 squared, subscribe 2 divided to 7 squared. Then we get 0.4082, right? And this is N2. N1, sorry. This is N2. N2 only 1 compares to 4. So it will become 1 subscribe 1 divided to 5 squared, subscribe 4 divided to 4, 5 squared, then we get the result. But as I mentioned, when it becomes a node, triangle node, then we have to weight it. I will change another color here. This will become here. Totally, there are 12 originally, but N1 occupied 7. So this value will multiple 12, 7 divided to 12, right? And the other part is 0, 3, 0, 3, 2. It occupies 5 divided to 12. So the summation will become 03714. Is that improved or not? Originally 0.5. Now 0.3714. Is that improved or not? Improved or not? Improved, yes. Improved how much? How much? We just subscribe, then we will get the answer. Improve 0.1296, right? Okay. But the square part, I think, is not easy for you. I will teach you how to use the Excel to do that. For example, here we keep the example here. We use Excel. First is the Y. This is a 5, 2, 1, 4. Then we start with this gene. Gene 1, gene 2. Okay, this equal. When you want to use the equation, please type the equal first. Then use the 1, subscribe. Five divided to 7. Square is shift plus 6. This is square. And 2 divided to 7. Square. Right? We just one format. Press the right button of the mouse and use the format here. And it could use the value. Please use the 4-digit. Okay, the same. Use the equation equal. 1, subscribe. The total number is 5. First is 1 divided to 5 square, and the other one is 4 divided to 5 square. Then is the answer. Then we weight it. We weighted this plus 7 divided to 12 and plus this multiple 5 divided to 12. So this answer, use the 4-digit percent. We'll get the same result, right? So again, what is again? Again means originally is 0.5. Stop graph the following. Then you get this. This is G's gain. This is Gini. This is Gini of the first node. This is the Gini of the second node. Okay. Okay, we take a break.